Hi dear students, welcome back to our channel Anvanay Kumar Basics of Physics. This is the right place to learn. Dear students, in this video we are going to discuss about one of the most important topic. Which rules we have to follow to draw the ray diagrams for image formation of lenses. Which rules we have to follow to draw the ray diagrams in case of lenses. This is the most important topic. If you can understand these rules, then only you are able to draw the ray diagrams. That's why watch very carefully. Clear children? So the first rule is on the board is that a ray passing along the principal axis is undeviated. The ray which is passes along the principal axis, that is undeviated, because according to Snell's law, the rays which are incident normally on a lens, they are undeviated. Clear? According to the Snell's law, which are incident normally, they are undeviated. That's why here the first rule is a ray passing along the principal axis undeviated. Principal axis వెంబడి పనిచేసే మూవ్ అవుతున్నటువంటి ఏ లైట్ రే కూడా deviate కాదు. So the same thing explained in case of a concave and convex lens. Children, I already told you, while we are showing like this, that lens is biconvex lens, convex lens, and if you are showing like this, it is a concave lens. So we have to remember these 2 points. With double head arrow, that is convex lens, and with 2 slits or 2 V shapes, what you have to say, that is biconcave lens. Look here children, for convex lens, so it is a biconvex lens, and already we know about that F1 and it is C1. F1 C1 is on right side and F2 C2 is on left side. Clear children? That's why here you have to remember those on which side we are taking F1 C1 and F2 C2 clearly. For that I already uploaded one video why we can take F1 C1 on this side and why F2 C2 on this side. For that you have to go to the previous videos and check it once. So children, in this diagram the red color arrow marks represents the light ray. It is the incident ray that is moves along the principal axis, and again that should be undeviated, it goes like this. The arrow marks indicates the direction of light moving. So that is about the convex lens children. So if you can take concave, now this is the concave lens. For concave and convex you have to observe. For convex on this left side C2 F2 it is there, for the concave on the first side C1 F1 is there. Clear? So again in this diagram also the blue color arrow marks represents the light that is moves along the principal axis, then there is no deviation of its after refraction also, it is like a straight line and that should be along the principal axis. So that is the first rule children. Now the second rule, what it is, the light ray which is passes through the optic center, it is also undeviated. The light rays which are incident or passing through the optic center, they are also undeviated. Undeviated means what? There is no change in their path. So అవి ఏ డైరెక్షన్లో మూవ్ అవుతున్నాయో అదే డైరెక్షన్లో మూవ్ అవుతాయి తప్ప there is no change in their path. Let's see that. Any ray, so rule number 2, any ray passing through the optic center is undeviated. Clear children? So now this is the for biconvex lens and this is for biconcave lens. So look here now, the ray is passing through the optic center. What is the optic center? Optic center is the midpoint of a lens is called optic center. So that's why here this is the optic center, this is the lens biconvex lens and it is its midpoint. Then the rays passes through the optic center, then there is no deviation. Same thing we can observe in case of biconcave lens also. So this is the optic center and the red color is the light ray that should be passes through the optic center, then there is no deviation in it. So children, this is the second rule. Children, now third rule, it is quite similar to the in case of concave mirrors what we discussed about the rules. In case of concave mirror, the rules which are we followed to draw the ray diagram, this is also same thing. That is what is the rays which are parallel to the principal axis. After reflection, they must be converge or diverge from a point. That is called here rule number 3. The rays which are going parallel to the principal axis. After refraction, the refracted rays are maybe converge to a point or diverge from a point. That point nothing but focus. Clear? Simply what you have to say, ఏ రేస్ అయితే ప్రిన్సిపల్ యాక్సిస్ ప్యారలల్ ఉంటాయో ఆఫ్టర్ రిఫ్రాక్షన్ అయిన తర్వాత ఒక ఫోకస్ అనే పాయింట్ నుంచి కన్వర్జ్ కావడం కానీ డైవర్జ్ కావడం కానీ జరుగుతాయి. ద కన్వర్జింగ్ ఈజ్ టేక్స్ ప్లేస్ ఇన్ కేస్ ఆఫ్ బైకాన్వెక్స్ లెన్స్ and the diverging can be takes place in case of biconcave lens. Let's go for that. Children, rule number 3, the rays passing parallel to the principal axis converge or diverge from the focus. That is the third rule. Look here, first we are taken biconvex lens, children. So double head arrow represents the biconvex. The red color lights what you are light rays what you are finding, they are parallel to the principal axis. This black color line is the principal axis. For it, these are the parallel. After refraction, they are focused at this point. Clear? So it is quite similar to the light is coming from infinite distance. After refraction, that should be focused at the point of focus. Already we discussed in the case of finding the focal length of a lens. Clear? So very simple. The light rays which are parallel to the principal axis, after refraction they should be focused at focus point F1 here in case of biconvex. And now here what do you say, the light rays are going to be converged. Here converging takes place. That's why it is called converging lens. Biconvex lens is called converging lens. Clear, children? And next thing, now it is the concave lens, biconcave lens. So in this case what you are finding, blue color lines, those are the incident rays and the red color is the principal axis. Clear, children? The line which is passes through C1 and C2 is called principal axis. Here also same thing, the horizontal line that should passes through the C1 and C2 is called principal axis. Clear? In this case also the light ray is parallel to the principal axis and these are the refracted rays. Those refracted rays are observed from this point focus. They are emanate or diverging from the F1. In the statement what you have, the rays passing parallel to the principal axis converge or diverge. That should be applicable in case of biconcave lens, children. While we are observing from this point, the light rays seems to be diverge from the focus. Clear? So this is about the rule number 3. Clear, children? Now we can go for rule number 4. The rays which are incident on a lens by making some angle, after refraction they will converge or diverge at a point in the focal plane. That is the rule number 4. Clear? When the light is parallel beam of light is incident on the lens, it will make some angle with the lens. After refraction they should be converge or diverge at a point in the focal plane. So look here, you will understand very clearly by looking at the diagrams. Rule number 4, when parallel rays making an angle with the principal axis fall on a lens, after refraction the rays converge at a point or appear to diverge from a point lying on the focal plane. Okay, children, now look here. So they will make some angle with the principal axis. This is the parallel beam of light. They will make some angle. So in the previous rule we discussed about the rays, they are parallel to the principal axis. In this case angle is 0. Clear? Now the rays are incident on the lens by making some angle with the principal axis. Clear? Those are the parallel beam of light. These are the parallel beam of light and after refraction they should be converged like this in case of convex lens. These two are not same, but it is the parallel beam of light and this is also parallel beam of light. Clear? In this case parallel beam of light will make some angle with the principal axis. Clear? After that refraction, they should be meet at a point. In this case, they are meet at a point on the principal axis. Now, in this case, they will be converged at a point. At a point on the focal plane. Here the question is, what is meant by focal plane? Here, now it is the principal axis, and the plane what we have taken in perpendicular to the principal axis, that should be called focal plane. It is the principal axis, and the plane what we selected, that should be perpendicular by angle of 90 degrees. Now that plane is called focal plane. So in that focal plane, at particular one point, all are converged. So in case of a biconvex lens. Clear? So that is rule number 4 in case of biconvex lens. The same thing we have to observe in case of biconcave. So here the black color light rays are they should be incident by making some angle. They will make some angle theta here. After refraction, again we have to extend the refracted rays back. They will meet at one point. That point in the focal plane. Now this is the focal plane. Clear? So when we are observing this from this point, the refracted rays are seems to be diverge. Clear? So this is about the rule number 4, children. So children, if you can understand this video, like, share, comment the video, and my humble request is, if you are impressing about the concept and explanation, so my request is you have to suggest our channel to your friends if they are not in our school, if they are in our school or than our school. Okay, I think the subject is helpful to them also. Thank you.